Okay, good evening, everyone. Great to have you all on board. The time with Tutor IO, the enthusiastic tutor, and in today's revision, it happens to be the very last revision class we have on the course, MTH106, and basically, just like it is written on the whiteboard, we'll be taking some theoretical questions and some calculations as well. So, with this being said, we're actually behind schedule. Nevertheless, we just have to do something. For those of us who haven't gotten the keynote of this course, let's do how to request keynote on our official website using the WhatsApp button you find on the top right hand corner, which is www.tutorial.net. And also, let's ensure to turn out for classes next semester early by reaching out to tutorial himself during the private class. Let's go straight into tonight's class without further ado. Okay. I think I need to adjust the camera a bit. All right. Awesome. Okay. Now, to start with, we're going to be starting with theory. Good evening. It's great to have you on board. We're going to be starting with the theory as it states. We're going to be taking some questions. Like, one thing with this exam is that it's not going to be pure calculation. All right. There is a striking of balance. If you are not so good with the calculation part, at least you can level up with the theoretical part. And that's how it is basically. That's how it's structured. So some persons might be lucky enough to have more of the theory. And some person might not be as lucky as having a lot of theoretical question to be more of calculation. But everybody's going to get a fair share of the theoretical part of the course. So we're going to be taking both the theory and the calculation tonight. All right, without much time, but in the little time available, should be able to achieve something. Okay. Good evening, Miss Yinka. Great to have you, Miss Immaculate. Rose, good to have you all on board. Now it says here, the very first question for tonight, it says two sets C and D are said to be disjoint. Their intersection is a dash set. Two sets C and D, all right, are said to be disjoint if, all right, there's a connected that says if and if only, if their intersection is a dash set. Is a dash set. If their intersection is a dash set. Okay, so we have that as a first question for tonight. Two are said to be disjoint if their intersection, what joins them together, is a dash set. Okay. Let's keep the answers rolling in. Wonderful, yes. If their intersection is a null, all right, if their intersection is a null set. Yes, wonderful. Yes, awesome. If their intersection is a null set. Wonderful. That means nothing. These two sets has nothing. All right, no connection. What a view. No connection at all. If their intersection, when we say intersection, that thing that joins a set or set of elements together. All right. If there is nothing there, then it's said to be a disjoint. Now let's take this. The rational numbers are closed under the operation of division except by dash. The rational, okay, the rational numbers are closed, okay, under the operation of division except by dash, okay, except by dash. So we have that question. So keep your answers coming in. Let's do well to respond to questions. Okay. Let's do well to respond to questions. Except by, okay, wonderful, yes, except by 0. Please pay attention to all this. You never can tell where your question will be set from. Pay detailed attention to all this. Now we have that as 0. So this is mathematics. You don't get to write your answers. If it has to do with figures, write it out in figures. Don't write it out in if it has to do with figures, write them out in figures. Don't write them out with alphabet. Now it says here, are we together? A simple and instructive way of illustrating the relationship between sets is the use of dash. A simple and instructive way. A simple and instructive way, okay, of illustrating the relationship between of illustrating the relationship between sets is the use of dash. When you want to illustrate, all right, the simple and instructive way of illustrating the relationship between sets is the use of dash. Okay, is the use of dash. Yes, we have that as Venula. All right, but it's okay to just write Venn diagram. Yes, thank you very much, everyone. Awesome. Yes, we have that as Venn diagram. Now we have it says here the power of set H is denoted by 2 raised to the power of dash. Okay, I think we are live. That was a thing from the service provider. I think we are live now. Awesome. Yes. So now the power of set H is denoted as, okay, 2 raised to the power of dash. The power of set H is denoted as 2 raised to the power of dash. Yes, wonderful. Awesome. 2 raised to the power of H. Yes, we have that as that. Wonderful. 2 raised to the power of H. Yes. So it's more like this. 2, then we have H. Then we talk about power of sets. So we have question 5. Okay. It says when you have something like this, n is equals to giving n equals to 2, 8, 10, 9, dot, 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 dot. All right. N is said to be, N is said to be dash. N is said to be dash. Yes, infinite. N is said to be infinite. Wonderful. Yes. So we have that as that. Can we squeeze one more question down there? I think yes, we can. Positive and negative whole numbers, zero inclusive, are known as dash. Negative and positive, all right? Negative and positive whole numbers, zero inclusive, are known as dash. Okay, are known as dash. Yes, wonderful. Integers, wonderful. Integers, yes, awesome. We have that as integers. So now let's take another set of these and we can move straight ahead to calculations. So we have question 7. It says real numbers that can be expressed as the ratio expressed as the ratio, okay, of two integers are called dash. Real numbers that can be expressed as the ratio of two integers are called dash. Or let's put this, are called dash numbers. Are called dash numbers. Okay. These are called dash numbers. I'm getting some nice responses already. Yes. Rational. Rational. These are called rational numbers. Yes. Called rational numbers. Now, question 8 says, a dash is called the combination of all elements. A dash is called the combination of elements. Okay. Wonderful. Yes. The answer of that is set. Yes, set. Wonderful. A set. Question 9. It says, this symbol, all right, is called a dash. All right, symbol you can see on the board, on the whiteboard, is called a dash. Okay. Is anybody helping with that? It's called a union. Awesome. Union. Okay. So what about this? What is it called? What about that sign? What is it called? Wonderful. Subset. Subset. Awesome. So we have that as subset. So we have question 11. Dash are numbers that is not a fraction. Okay, let's not take this. It's a little bit complicated. Or probably we can just repurpose that question. Okay, now let's take this. It says on a real line, the center represented by 0 is called the dash. On a real line, the center of the line represented by 0 is called dash. Is called dash. Origin. Awesome. Origin, yes. It's called the origin. Wonderful. Now let's take this. It says here, okay, just a moment. Series of payments over a period of time, such as bonds, coupon, is referred to as dash. Series of payments, okay, over a period of time, over a period of time, such as coupon, all right, bond, etc., are called dash. Are called dash. Okay. Wonderful. Yes, we have that as annuities. Okay. annuities. It's a lot of theory, all right, from this end, but in order to save time, let's just go for the calculations now. Let's take our bearing from set theory, and some good examples will be highlighted in a moment. For those of us who are here to get the keynote of the course, ensure to reach out to me on www.tutorio.net. You find the WhatsApp button on the top right hand corner. Use that to send me a direct message. Okay. So we have the calculations now. Let's start with okay. Let's start with this. Let's touch a few of them. We have a long list. Okay, for those of us who are not aware, we have a long list of all the calculations we've taken earlier on this course. All right, is in the keynote. The keynote is subdivided into two: the theory and the calculation. Everything's arranged for you accordingly. And in less than 2 hours, we are done with all these calculations, and you can understand it because I broke them down into bits, explained them properly. Division, I'm just going to touch on very few of them just to brush us up on what we have learned retrospectively. Now, let's start with sets. All right, there's something called equality sets. Okay, equality sets. Now, when we say equality, what are we referring to in essence? Okay, equality sets simply means that the set, all right, of A, let's say A equals 1. The elements of set A are 1, 2, 3, 4. And we have set B. We have 3, 2, 4, all right, and we have 1. With this, we can say A equals to B. Why? Because all the elements in A are also found in B. Then we have it as equality set. Also, we have, I made mention of it earlier, something called subsets. Okay, when you say subsets, let's take for example, the elements of set C are 1, 3, 5. Okay, 1, 3, 5. Then we have the element of set D. We have 5, we have 4, we have 2, we have 1, we have 3. Now, from what we have here, you can see that every element in set C is in set D. We have 3 here, we have 3 here, we have 1 here, we have 1 here, then we have 5 here. So we can say set C is a sub, all right? So we can say set D is a sub. Wonderful. So now it says power set. I was trying to, we got a question from the theory on power sets. Now, when we say power set, this is what we have on power set. On power set, it says, this question also came out a lot in the TME, power questions on power set. is let f, all right, let f equals, all right, the power set of f. So now, power set of f. Remember what we said the other time? That we said 2 raised to the power of f. Okay? 2 raised to the power of f. Then let the elements of f be, okay? Let the element of f be a and b. So this is what we're expected to do. We're going to open a big, right? A big one. Then we have f, okay? Then we have a small one, whereby we have a first. Then a next one, whereby we have, this is comma, whereby we have b next. All right? And we'll close that. And there'll be, now to start with properly, all right? To start with properly, we'll put together, okay? We have A and B. Then a smaller one, we have only A. All right. Then another one, we have only B. All right. Then another one, whereby we have a null set. Then we close it on. And that is the process. Okay. So now let's take something a little bit longer than this. So now let's say, for example, we have power set of Z. All right. So the set of Z are 2, 6, and 8. So what are we expected to do? And the power set of Z will then be, okay, start with, we have Z, okay, we have Z, then we have the first 2 numbers, which is 2 and 6. Then we'll pick the next one, which will be 2 and 8. Then we stop. The next thing to do now, all right, the next thing to do is to break it if you want to, all right, is to break it, then start another, which we have. This time around, we are taking 6 and 8. Okay, we are taking 6 and 8. So before I close this, let's put this here. I need to break that. So now let's comma. We have 6 and 8. If there was another number, that's how it continues. But since there is none, then we can close that. Then we'll have individuals. Okay. Now sometimes this one can be here, sometimes might not be there, but let's just, since we are doing for the set of Z, so then we'll pick individuals now, whereby we have 2, all right, we have 6, we have 8, then we close that. Okay, and the next one will be for the null set, which is, all right, null. And that's all. Sometimes it might even come in this way, whereby you have Z, then you have this. Okay, so that's that on the power of set. So now let's erase this and take something else. So let's take a number line and we'll call it a wrap for today. All right, real number. Okay. Now for real number, we have 4 minus, all right, 4 minus is less than y. If you are to have this real number, all right, what are we expected to have? Real number has 2 sides, the negative side and the positive side. So since this is the negative side, let's just focus on it. All right. Since this is negative side, let's just focus on it. This is the origin. Then we have 1, 2, 3, 4, 5. All right. This is -1, -2, -3, -4, then -5. All right. So here is representing our y, and here is representing our x. All right. So this is negative. So where are we taking this from? Now, pay attention to that. It is not equal to, less than equals to. So this will not be shaded. All right. And it will head towards the origin. All right. But if it was less than equal to, this would have been shaded. All right. So note that, please. Okay. So now let's also take this. It says 5 less than equals to x. So we have origin 1, 2, 3, 4, 5. All right. So this is our y and this is our x. Okay. And since this is 5 less than equals to x, then we have this shaded. All right, heading straight for the origin. Okay, there are a whole lot more of these, all right, that we have treated in the past, and they are all arranged in the keynotes just for us. So let's do what to request the keynote immediately after this class, so we can make the best, all right, out of this course. I want to wish you all the best and success in your exams tomorrow, and I'm expecting nothing less than, all right, A and B from each and every one of us in this course in particular. Now, like I said earlier, for those of us who need the exam keynotes, just reach out to us on our official website, www.tutorial.net, and use the WhatsApp button on the top right hand corner to send to our direct message. Do have a wonderful evening, and bye for now.